Right, when we take a look at this problem right here, okay, so it says 8 to the 2x minus 3 equals 16. Well, when you look at 8 and 16, right, 16 can't be expressed in a base of 8, 8 can't be expressed in a base of 16. However, can you express either one of those using a different base? Yeah, 8 is 2, the base 2 cubed. And 16 can be expressed using that exact same base 2, and it would be 2 to the what power? To the 4th, right? So here you can continue using the properties of exponents. When you take a power to a power, you do what? Multiply. So we take 3 times 2x minus 3 and 2 to the 4th. And so you can, if you want, you can equate your powers right here. You have the bases the same. And when I equate these powers and solve the resulting equation, you can distribute here. 6x minus 9 equals 4. Add 9 to both sides. I get 6x is equal to 13 over 6. And I get my solution. Right, when I double check this, I plug it back in, I get, in this particular case here, I get 8 to the 2 times 13 6 gives me 13 thirds, minus 3 is 9 thirds. So I'm left with 8 to the 4 thirds, and we're testing to see is that equal to 16. Well, remember, when you take a rational power, you can apply the power or the index first. The denominator is the index. So I'm going to take the cube root of 8, which is 2. Is 2 to the 4th equal to 16? Yes, and so that checks. Hey, what's the base that you can write each side of this equation in terms of? 3. So 27 is 3 cubed to the x minus 1. 81 is 3 to the 4th. When you take a power to a power, you multiply. You can equate the powers here. When you equate the powers, we get 3 times x minus 1 is equal to 4. Solve the resulting equation. 3x minus 3 is equal to 4. Add 3 to both sides. 3x is equal to 7. And when you solve for x completely, you get your answer 7 thirds. Okay, let's check our solution. Okay, if we plug this in, we get 27 to the 7 thirds minus 1 is 3 thirds. So that's going to leave us with 27 to the 4 thirds. And we want to test to see, is that equal to 81? Well, again, we can take this base 27 and either apply the power of 4 or the index, which is the nth root or cube root. Easier to take the cube root of 27 is 3. 3 to the 4th is 81. That is equal to 81. So once again, it checks. How'd it go? All right. Okay, so again, it's the same process. You look to rewrite each side of the equation using exponents with the same base. So what's the common base we can use? 3. So 9 is 3 squared to the power of x squared. And then the right side, we don't have to change anything. Apply the power to a power, we multiply. So 3 to the 2x squared equals 3 to the 3x plus 2. Equate our powers here. So 2x squared is going to equal 3x plus 2. And solve the resulting equation. It just so happens this turns into a quadratic equation with multiple terms with variables. So move everything to one side. Subtract a 3x and subtract a 2. Okay, and now you can solve this either by trial and error or rewrite the middle term. I'm going to go ahead and rewrite the middle term here. So I take my leading coefficient, my constant. 2 times a negative 2 is negative 4. Are there two factors of negative 4 whose sum is the middle term's coefficient, negative 3? Negative 4 and a positive 1. So if I rewrite my middle term as those, drop my first and last terms down and factor by grouping, get a 2x, leaving x minus 2, plus there's no common factor, so leave that or write a 1 so you can remember to use it. Leaving an x minus 2, I have this common binomial factor, and the factors that remain form the terms of my other binomial, 2x plus 1. And then when I use the zero product rule, set each of these equal to 0, I get x to be, what value of x gives you a 0 in the first factor? 2. Again, it's just the opposite of the constant divided by the coefficient. And then the second one, same thing. Opposite of the constant, -1, divided by the coefficient, 2. Okay? It's a good idea to check your answers as well. Okay?